Hello students, in the last video lecture we talk about the definition of the Hamilton function and the theorem based on the Hamilton function. So what we talk there, we prove there that Hamilton function that is denoted by capital H, that will be the sum of the kinetic energy and the potential energy. That means capital H denotes the total energy of the system actually. Okay, so for today our first definition is Hamiltonian function. What will be the Hamiltonian function? Hamilton introduced the function h of t qi pi is equal to summation pi into qi naught tilde minus L tilde. Where this qi tilde, what does it mean? Qi tilde means wherever the qi dot is there, that will be replaced by capital Qi of t qi pi. And what does it mean L tilde? L tilde means wherever the qi naught present in L, that means Lagrangian function, wherever the qi naught present in L, that is replaced by capital Qi of t qi pi. Okay, so this type of the function is known as the Hamiltonian function. Next we have a theorem, Dunkin's theorem, which is very important. So what the theorem says, given a certain function x of x1, x2, x3, xn, and determinant of curl square x over curl xi curl xk, where ik varying from 1 to n, that determinant is non-zero, and let there will be a transformation of the variable generated by the function x. So that means by using the function x, we are making a transformation curl x over curl xi, that is equal to yi. So this transformation is given. So for this transformation there exists a transformation, that transformation which will be generated by function y. As in above, there is a transformation of this which is generated by capital X. So similarly here there is a transformation which will be generated by this function capital Y, and what will be the transformation? Curl y over curl yi is equal to xi. Okay, so this thing you have to prove. Okay, for suppose this is a direct transformation, for this direct transformation there exists a inverse transformation of this type. But what is the relation between this x and y? So there is a relation. So I am writing down over here, the generating function the generating function y of the inverse transformation is connected with the generating function x of the direct transformation, which is connected by this relation. Okay, capital Y is equal to summation xi yi minus of capital X. Okay, if this capital Y and capital X is connected by this relation, then you have to show that for this transformation this will be exist. Okay, this thing you have to prove. Now later on, if the function x contains the parameter alpha 1, alpha 2, alpha m, that means along with x1, x2, x3, xn, alpha 1, alpha 2, alpha m is also there in capital X. So if it contains these parameters, then capital Y also contains these parameters, such that curl y over curl alpha j equal to minus of curl x over curl alpha j. Okay, so this thing we have to prove. Now come to the proof. What is given here? Obviously it is given that a function capital X of x1, x2, x3, xn, and what else is given? Determinant of curl square x over curl xi curl xk, where I is varying from 1 to n, that is non-zero, that in determinant is non-zero of all second order derivatives. And we are saying that one transformation is given, curl x over curl xi is equal to yi. This transformation is given. Okay, what it can be says? It can be says that this is the Jacobian of curl x over curl xi. Okay, but curl x over curl xi is denoted by yi. So you can say that this is the Jacobian of yi, which is non-zero. Okay, in the another way you can say that this is the Jacobian which is non-zero. But by using these values, I will say that xi is a function of y1, y2, y3, yn. Okay, xi is equal to fi of y1, y2, y3, yn, where I is equal to 1 to n. Okay, but how it will be? You can say that we have given these values. By using this value, you have to show that xi is a function of y1, y2, y3, yn. So for this, I just take some example. So I have written this thing over here. You can check it. Okay. So let me enlarge it. When we talk about this thing, so you see. Suppose that I am considering capital X as x1 square plus x2 square plus x3 square plus x1 x2 plus x2 x3. Okay, I suppose. But if I take the partial derivative of this capital X with respect to x1, with respect to x2 and with respect to x3, if I find out. But you know that transformation is given here. Curl x over curl xi is equal to yi. So curl x over curl x1 will be equal to y1, curl x over curl x2 will be equal to y2, and curl x over curl x3 will be equal to y3. Okay, we write down these things by using the transformation. Now we find out these derivatives. X is there. So what it will be? Curl x over curl x1, that will be equal to 2x1 plus x2. Right? If you find out the curl x over curl x2, so this 0, this will be 2x2, okay, and that will be 0. And if you find out, this will be, that will be x1, okay, and plus that will be x3, right? So plus x1, what it will be there, okay. And if you find out the derivative with respect to x3, so what it will be? So if you find out the partial derivative with respect to x3, so you say it will be 0, 0, and that will be 2x3. And when you find out, this will be x1, x2, that becomes again 0. Okay, and you find out the derivative with respect to x3, so what it will be? It will be x2. So you will write down that will be x2 over here, right? So that means when you find out the first derivatives, that will be equal to this thing. But again, if you find out the derivative by using curl square x over curl, if you find out the derivative of this with respect to x1, with respect to x2, with respect to x3, so I am writing down this in matrix form. I am writing down. Okay. So write down when you find out the derivative of this with respect to x1, so it will be curl square x over curl x1 square. So what it will be? It will be 2. When you find out the derivative with respect to x2, curl square x over curl x1 curl x2, that will be 1. When you find out its derivative with respect to x3, that will be 0. When you find out the second, when you find out the derivative of curl x over curl x2 with respect to x1, what it will be? So you will say that it will be it will be right, it will be 1. Then when you find out with respect to x2, that will be 2. When you find with its derivative with respect to x3, that will be 1, right? So when you find out the derivative of y3 with respect to x1, that will be 0. And you find out its derivative with respect to x2, that will be 1. When you find out its derivative with respect to x3, that will be 2. Okay, so this thing we are getting, right? So what else will be there? So by using this thing, you can check that when you find out its derivative, it will be this one. So when you find its determinant, so determinant, what it will be? That will be the determinant. You find out and calculate. So when you find out its derivative, so that means if you find out the determinant, what was the determinant? That was 2, 1, 0, and that was 1, 2, 1, and 0, 1, 2. Okay, you make the editing here. This is plus x1, and this is, there is plus this is plus x. This respect to x3, this is plus x2, right? Here. So when you take the partial derivative of this thing with respect to x1, x2, x3, of this equation with respect to x1, x2, x3, of this equation with respect to x1, x2, x3, then you find out the determinant of these coefficients. So that will be the determinant. So that determinant, when you solve it, this value you can check that, solve it and check, this value is 4, which is not equal to 0, right, which is not equal to 0. Then what does it mean? That means for this x, determinant of curl square x over curl xi curl xk, where is ik is varying from 1 to 3, this is non-zero. Okay, if this is non-zero, so you can check that. Okay, what does it mean? This is the determinant of, if you write down this system can be written as y is equal to ax, right, where left hand side y1 y2 y3 is equal to y, denoted by this matrix is y, and coefficients will be written in denoted by capital A, and the remaining coefficient x1 x2 x3 will be denoted by capital X, right. So that A is the matrix whose determinant is this thing, okay, and which is non-zero. So by the system of the linear equation, you know that if this determinant is non-zero, that means A inverse exists. If A inverse exists, that means you can say that x will be equal to A inverse y. Okay, so what does it mean? That means this xi will be a function of y1 y2 y3 yn. I mean y1 y2 y3. For this case, you can say that be a function of y1 y2 y3. Okay, for I varying from 1 to 3, means x1 is also a function of y1 y2 y3, x2 is also a function of y1 y2 y3, and x3 is also a function of y1 y2 y3. Okay, so by using this calculation, you can say that in this general case, for our case, you can say by using these values, you can say that xi is a function of y1 y2 y3 yn, right, where I is varying from 1 to n. Now what you have to do? You have to show that for this y, suppose that there is a function capital Y, which is a function of y1 y2 y3 yn, and it is defined by this capital Y is equal to summation xi yi minus capital X, okay, minus capital X. So there is no summation, this is not the bracket here, okay, it's not a problem if bracket is there. Okay, so this will be this one, or you can say that y can also be written as k is varying from 1 to n, xk yk minus capital X. Okay, so what you have to do? You have to find out the partial derivative of this capital Y with respect to yi. You have to find this thing. So come to this point, when you find out the partial derivative of capital Y with respect to yi, so it will be curl by curl yi of this thing. Place the value of y, it is this one. So when you take the partial derivatives, you can check, there will be the product rule applied. Okay, take the derivative of xk with respect to yi into yk as it is, okay, plus take the xk as it is, take the derivative of yk, okay. But for y equal to 1, 2, 3 and so on, when you take its derivative, you got that ki curl y1 over curl yi, that becomes 0, so that part will be 0, okay. Curl y2 over curl yi, that becomes 0, okay. So when you all the derivatives you take, that becomes 0, but curl yi over curl yi, that becomes 1, or yi coefficient will be xi, right. So that means it will be xi, and minus when you take the derivative of capital X with respect to yi, but x is a function of, you know that x is a function of x1 x2 x3 xn, right. So when you take the derivative of x with respect to yi, so what it will be? Curl x over curl xk into curl xk over curl yi, okay, by the chain rule you can say. So it will be this one, right. But this transformation is given curl x over curl xi, that was equal to yi. This is given here, this is given in the statement. So that means curl x over curl xk, that will be replaced by yk, right. If this is yk into curl xk over curl yi, and similarly this is yk into curl xk over curl yi, k is varying from 1 to n, this is of opposite sign, these values. So that means these value will be cancelled out. So what will be left here? Only xi will be left. So this explanation is given below, okay, you can check that. This is given here, right? When you find out the derivative of capital X with respect to y, this will be this one, इसे हमने यूज किया, and curl y over curl yi, when you place this value, it will be this one, same sign or opposite sign, that will be cancel out, that will be y xi. So that means we proved that curl yi over curl yi will be equal to xi. Okay, so this inverse transformation we have proved. So what else is left? One more thing is left. Now we suppose capital X contains the parameters alpha 1, alpha 2, alpha m in addition to the variables x1, x2, x3, xn. Okay, then what will be there? If alpha 1, alpha 2, alpha m is contained in capital X, then you know that what we have, if in this X alpha 1, alpha 2, alpha n is included and these conditions are there, so what we have prove here, we said that xi is a function of y1, y2, y3, yn. So that means there also xi will be a function of y1, y2, y3, yn and alpha 1, alpha 2, alpha m. Okay, so xi will be a function of this thing. So you can say that if so you say that will also contain in the inverse transformation, right? So what we have, capital X is a function of x1, x2, x3, xn and alpha 1, alpha 2, alpha m, and we have said that xi is a function of y1, y2, y3, yn and alpha 1, alpha 2, alpha m. Now what you have to do, again you have to find out curl y over curl alpha j. This thing you have to find, and you have to prove that this will be equal to minus of curl x over curl alpha j, right? So we will calculate this thing first. So it will be, obviously it will comes to that point. Okay, so we take that curl y over curl alpha j. So when you find out curl y over curl alpha j, but you know that what was y, capital y is equal to summation xi yi minus capital X, where I is varying from 1 to n, right? So when you take its derivative with respect to alpha j, what will be, curl of y over curl alpha j will be equal to curl by curl alpha j of this thing. Okay, यहाँ पर x is given by this value, right? So you find out, and small xi is a function of this value, right? So you can check that when you take its derivative, again product rule you apply, curl xi over curl alpha j into yi as it is, plus xi as it is, curl yi over curl alpha j, okay, minus when you take its derivative with respect to alpha j, what it will be, from here you can check that this x is a function of x1, x2, x3 and xn, alpha 1, alpha 2, alpha m. So what it will be, you will say that curl x over, you will say that will be curl x over curl alpha j. What it will be, by using the chain rule, you will say that first we take the derivative of x with respect to x I into curl xi over curl alpha j, okay, and plus curl x over curl alpha j into curl alpha j over curl alpha j, okay. So that becomes 1. If this becomes 1, so this will be left here. So this thing I have written over here. यहाँ पर आप check कर सकते हो, it is written over here. Okay. I also give this explanation below the page. So you can check that this will be this one. But you know that curl x over curl xi, this is y. So I use this transformation, this is yi. Okay. Now xi is a function of y1, y2, y3, yn and alpha 1, alpha 2, alpha m. Therefore this will be as it is. So curl xi over curl alpha j into yi. This is as it is, and this is xi. When you find out the derivative of yi with respect to alpha j, so this is independent of alpha j. So you will say that will be 0. So this part becomes 0. Okay, and minus sign will be there, minus of this term, minus of this term. So these are of opposite sign. This term and this term are of opposite sign. So this will be cancelled out. So it will be left here, minus of curl x over curl alpha j, right? So this is the required proof. Okay, for this thing I have proved this later on in this page. You can check when you are finding capital X was this one. So you can check that whatever I have talked earlier, this thing. Okay. So individually when you find out, this becomes 0, that and second term becomes 0, that term becomes 0. But wherever alpha j is there, curl alpha j over curl alpha j becomes 1 and curl x over curl alpha j is left. So this is there. So this thing I used above. Okay. So by using this thing, you got the proof curl y over curl alpha j will be equal to minus of curl x over curl alpha j. Okay. That was the proof of the Duncan's theorem. The next topic we will discuss in the next lecture. Thank you very much, class.